Hey guys, if you have an oscilloscope like this, you probably have wondered what the percentage markings on the display are for. Well, they are for measuring rise time. What's rise time? Let's look at a square wave to see this. It's very easy to see what's happening, and it's also a very, very common example of when you're going to use a rise time measurement. Here's our square wave. The rise time is the time the waveform takes to go from low to high. The amount of time taken for the voltage to rise. Fall time, on the other hand, is just what it sounds like, the time taken for voltage to fall from high to low. To demonstrate how this is done, I'm just going to use a simple transistor multivibrator. You can find the schematic online. I think I'm going to put a link in the description, but it's a very simple circuit. I think if you have an oscilloscope, you've probably either made this circuit before, or you won't have any troubles making it whatsoever. Now, I've got this hooked up to the oscilloscope, and you can see the waveform. Now, I lied to you a bit earlier. I said that the rise time is the amount of time the waveform takes to go from a low to high state. However, while this is the case, it's not exactly true. When measuring rise or fall time, we don't measure from the 0% to 100% voltage. We measure from 10% to 90%. Why? Well, it's in case your waveform looks like this. You can see there's a substantial ringing at the bottom of the waveform, and the top edge is pretty rounded over and ugly. Not really what we want for an accurate measurement, especially when you're just learning. So, for this tutorial, because of that, I'm going to keep the signal relatively ringing free. So how do we measure rise time anyway? Well, we start by lining up the bottom of the trace with the 0% line on the oscilloscope screen. Now that you have this lined up, you have to get to the top edge to line up with the 100% mark, using the method as follows. Now, what is this method? Well, this is what the quote-unquote uncalibration knob is for. On most oscilloscopes, you'll have a knob like this in the center of your volts per division knob. What's it do? Well, it adjusts the voltage per division by an arbitrary value, skewing it from the set value. This renders voltage measurements useless, but it keeps time measurements okay, and since all we care about is time, this works perfectly. I'm going to adjust the knob until the top of the waveform lines up with the 100% mark. Now I'm going to use the 10x multiplier on my oscilloscope to zoom into the waveform and still keep it movable across the screen. However, you don't need to do this. If you have a delayed time base, you can use that as well, whatever you're comfortable with. Now line up the point where the trace crosses the 10% line with a vertical line, like so. Now simply count the divisions between the 10% crossing and the 90% crossing. I've counted 2.6 divisions here. Looking at the time base knob, we can see that it is set to 0.5 microseconds per division. However, we have the 10x magnification on, meaning that the time is divided by 10, resulting in an actual time base of 0.05 microseconds per division. The rest is easy math. Simply multiply the 2.6 divisions by the 0.05 microseconds that each represents, and we get a result. In this case, 0.13 microseconds. That's it. That's the rise time. Now to measure the fall time. Wait, it's exactly the same as rise time. The only difference is you're measuring the time to drop from 90% to 10% instead of rise from 10% to 90%. Anyway, that's it. I hope this video helped you, and if it did, give it a thumbs up. If you have any questions for me about this or anything else, throw a comment down below and I'll try and answer it to the best of my ability. And if you want to see more videos like this, please subscribe. Thank you. See ya.